have an SOL in the very first week of May. So the snow days are really fun. That's great. That date's not going to change. We also have a test coming up on this. That date's not going to change either. Who cares? So I just need you focused. All right? We only have another half an hour because of this. I need you focused. Not a lot I've been finding funny today. I will say that. All right. Let's review now finding products. X plus 3 squared. Now I just want to say one thing about this. You know what it's not? It is not x squared plus 9. It is not that. Now let's think, well, why would it be x squared plus 9? We might want to just say square this, square that. Why can't I do that? Isn't the rule the 2 applies to both things? Isn't that the rule? Except what? What's wrong? Add. It's an add. So when do we just apply the 2 if this was a multiply? It's not a multiply. It's an add. So don't just apply the 2. Don't do it. Let's expand this. What does this mean? X plus 3 squared. It says you have 2 factors of x plus 3. Yeah. So you want to write that twice, and you can just use multiple distribution or FOIL, however you want to think about it. So x times x, x squared, x times 3. Yeah? Okay, so we distributed the x. Now let's distribute the 3, or think of that as the inside and the last. 3 times x, and 3 times 3. So I see some like terms here. So x squared plus, what's 3 x's, and you have 3 more x's. 6x. So this is x squared plus 6x plus 9. Okay, so what is this not? What is it not? It's not x squared minus 4. Not. Not. So we want, or plus 4, yes. Either way, it's not that. Let's expand and use multiple distribution or FOIL, however you want to think about it. X times x. X times negative 2. I'll never go this way. Negative 2 times x. And then negative 2 times negative 2. Plus 4. And look at that. We can combine those very often. The OI and the FOIL can be combined. Negative 2x minus 2x is negative 4x. So this is x squared minus 4x plus 4. What about this guy? Not 9x squared plus 16. Not that. Because I don't just square these guys. I need to expand. So 3x times 3x. 9x squared. Right? 3 times 3 and x times x. 3x times negative 4. Negative 4 times 3x. Negative 4 times negative 4. Plus 16. I've got my OI here combined. 9x squared minus 24x plus 16. 9x squared minus 24x plus 16. Do we see any pattern with these? Do we? What's going on with these? Yeah, what do you think?
It's all going to be the square number x and
We're always going to see, right? You're going to see the x squared and the 9. Here they are. How do I get the middle? I agree, right? That is part of the pattern. Square, square. What? Well, how do I get the middle without actually multiplying? Looking for a pattern. Like this 6x, it came from this 3x. This minus 4x came from this minus 2 and an x. This minus 24x came from minus 4 and a 3x. Do we see a pattern? Anybody?
No. We multiply to get the middle and
And then multiply by the square. You're right. 3 times x times 2 and y times 2. Because you're going to have the same thing on the outsides as you have on the inside. See how that works for all of them? So if you have any number, any binomial square, that's going to be this thing squared plus the outside thing squared. And I'm going to put it over here. What's your middle term? This thing times that thing. What's a times b? AB times 2. Because you're going to have 2 of them. Now, yeah, it's just a pattern to make this faster. I will give you this. This is a real nice to have. And some people latch onto this right away. If you don't remember it, what do? Expand them out and multiply. So is this like you must remember this by next class right away? I'm going to say it's a nice to have right now. Yeah, absolutely. The important thing I want you to take away from this is expand them out and use a FOIL if you don't remember the pattern. Don't just multiply the two things. There's a middle. So make sure you expand it unless you can remember this pattern. I will understand if you can't remember the pattern. It's just kind of new at this point. This one, on the other hand, let's look at this guy. I've got an x plus 2 and an x minus 2, and I'm multiplying. So let's use FOIL. X times x, x times negative 2. Okay, so that's my x distributed. Now I'm going to distribute the 2. 2 times x and 2 times negative 2. I can combine my middle terms. Now what happens to my middle term? I've got a negative 2x and a plus 2x. They cancel out, right? They zero. They're opposite numbers. X squared minus 4. Let's try this guy. X plus 6, x minus 6. Same idea. So I've got x times x, x squared. X times negative 6, negative 6x. Distribute that 6. 6 times x, positive 6x. 6 times negative 6 is negative 36. What's happening? They cancel out. The OI is canceling out. Let's try with this guy. What's 2x times 2x? 4x squared. 2x times negative 1. 1 times 2x. 1 times negative 1. Look what's happening here. Again. Cancels out. Now what is the pattern we're noticing here?
Reverse the sign.
Yeah. So look how these are the same thing. These binomials are the same except one's a plus, one's a minus. When you have that situation, the outside and the inside will always cancel out. So this one will be, just multiply the first, multiply the last. So if you have anything, a plus b and an a minus b, the only thing different is the plus and the minus, a squared minus b squared, because these outsides and insides will cancel out every time. Now this one, yes, remember this. This one I think is kind of an easier one to remember. And if you don't remember it, go ahead and do the outside, the inside. You'll just find they cancel out. But this one is a real handy one to notice. Oh wait, it's a sum and a difference. That's that pattern that says I don't have to worry about outside and inside. So yes, this one, great if you can. Don't worry if you can't. Just multiply and you kind of get the rule back. Don't worry about that one so much. This one I want you to start really recognizing. It's the same thing with the plus, same thing with the minus. Don't worry about outside, inside. Okay? So again, here's just general patterns. Now I'm going to use the rule here. You square this guy, and you square that guy. And he's always going to be positive, because if that was a minus, you get a negative times a negative. Then what do? This times this, a times b is ab, times 2. That's the pattern. If you don't know the pattern, just go ahead and expand it. Use your FOIL, use your multiple distribution, you get it back. Same thing with this guy. Binomial squared. Square that guy. Negative b times negative b, that's a plus b squared. Multiply times 2. A times negative b is negative ab times 2 negative 2ab, using the pattern. Again, this pattern, if you don't see it, don't worry about it. Expand out and use multiplication. Yes?
So how did you get the, like, for the first one and the second one, the a squared minus 6 plus 2a, blah, blah?
I'm remembering the pattern that we discovered when we multiplied out. You multiply this guy, you get a squared. Here's a negative ab, here's another negative ab. That's why there's negative 2 of them. And then here's my last. And again, if you don't worry about the pattern for this one yet. If this is just too much at this point, don't worry about the pattern, multiply out.
Okay.
Okay?
No, since you can't remember it, then
Just multiply them out. Multiply them out. Now this guy, I would like you to remember. It's the same, except one's a plus and one's a minus. So what's the rule say? Don't worry about outside, inside. So it's a first and a last. It's an a squared minus a b squared. This one, yeah, I would like you to remember. Now, if you do forget, you multiply it out. You'll just get there again. You'll get there again. Okay, so we know these patterns. So these are nice, real nice. And this one I really want you to have, because we're going to need this very soon. Have in your brain. And most people say, well, this one's kind of easy. It kind of is. And again, I forgot. Here's a negative AB, there's a plus AB. They'll cancel out if you multiply. Okay? So that's all that really is. There's a whole bunch of practice. Since we don't have a lot of time today, I'm going to just ask you to do A here and A here. And this is on the bottom of page 1. Just do those two. I think they're on the bottom of page 1. Oh, there they are. Just do those two. And then we'll move on. I'm using the patterns because I've been doing this for several hundred years. If you don't remember the patterns, okay? This one I want you to use a pattern. You can expand this guy out if you need to. That's fine. Don't worry about it. This one I kind of want you to do. You have questions? Are we getting there? Yeah. What's your question? She had a good question. What do you do? What's 7x times 7x? What is 7x times 7x? What's 7 times 7? 49x squared. And what's f times f? This is my sum and difference pattern. So I just multiply the positive 1 and the negative 1, 49f squared minus 1. These should be easy. What's this one? What's this one? It's 4 times 4 times. Yes. That's all that you do with that. Question. Because what's 9 times 9? Right? So this one, y times y times 9. 9 times y, 9 times 9. The 9y plus the 9y is how I got the 18y. Yes?
So when you're doing, like the AF there, it's always going to be something squared, and then it's like two of the same thing combined, correct? Two of the same thing, so like.
If you want the pattern, here's the pattern. Square this guy, square that guy, multiply that times 2. Again, if pattern is too much, don't worry about the pattern. Okay? All right, here comes the good stuff. I'm skipping this for now again because of these snow days. They need to stop. They do. All right. All right, look, long division. Remember long division? Now, really?
Yeah, really.
No.
Really.
I hate it for one.
What am I circling? Let's just say, how do you do this? You say 3 times what number gives me 6? Well, now, let's think about how you get that. How'd you know that? Because 6 divided by 3, you took the 6, you divided by 3, you came up with 2. You did. And then what do? You multiply. You say this times this. What's 2 times 3? 2 times 3. 6. Then what's our next step in long division? Subtract and bring down. This should not be, oh my God. This should be like, oh yeah. Then what? You say 3 goes into 9. What number times 3 gives you 9? And you can say, I can't remember. Let's do this 9 divided by 3, which is? Really? What number times 3 gives me 9?
3.
Thank you. Then we do a multiply step. 3 times 3 is 9. We do a subtraction step. We bring down. 3 times what number gives me 3? 1. And 1 times 3 is 3. When we do our final subtraction, we have a remainder 0. Right?
Yes.
This should not be like news here. Now let's try it again. So you say 4. Gee, how many 4s can I fit into 7? Multiply. 1 times 4 is 4. Then what we subtract. 7 minus 4 is 3. We bring down to 2. Then we say 4 goes into 32. How many times? 8. We do a multiply step. We subtract. Then we bring down 9. 4 goes into 9. How many times? 2 times. We multiply and we subtract. Now there are a number of ways your third grade teacher might have said what you do You can say 182 remainder 1. You can make these little decimals and start bringing down zeros, remember that? Or we can write the remainder as a fraction. You take this 1 and you put it over your divisor. And I get multiple, a lot of people say, I have never seen this in my life. Is that true?
Yes.
What do we have for third grade? Because we need to email them and say, this did it.
Mr. Fazini.
She never taught you this? Really? Well, I'm teaching it to you. If you have a remainder, you put it over your divisor, and now 182.14 times 4 will give us 729. That's how it works. It does. And you can actually multiply that, right? This times this will give me that. This times this will give me that, right? That's how we verify. So now, we're going to apply this to our polynomials. Okay? I'm first going to start. If you want it to be hard, it will be hard. Or you can just say, I can do this. I'm just going to pay attention. Because the process is pretty much the same. So, let's see what I got here. I've got an x. I'm dividing everything by x. X times what gives me x to the third power? Or you can think of it as x to the third power divided by x. Right? This divided by that. Which is what? X, so x to the second power. Then what do? You multiply, right? This times this. X squared times x. X cubed. Do a subtraction. Bring it out. And then we look at this guy and say x times what is 4x squared? And if we don't see it right away, well, let's divide it. 4 over what? What's x squared divided by x? What do we do with these exponents? X squared. This is x, right? 4x. Now we multiply back. 4x times x. 4x squared. Then we subtract. And then we bring down. Right? Isn't this exactly the same step, really? Yeah, it is. But you have to think like now in polynomial terms. X times what gives you 5x? And if we can't see it, take your 5x and put it over your divisor. And the x over the x is a big old one. 5. 5 times x is 5x. And there's my remainder, no remainder. So this x squared plus 4x plus 5 times x is this. And you can multiply backwards, right? You get this one. Another way to think about these is write it as a fraction. For a monomial division, sometimes this is easier. Are these things equivalent, these two? This is easier because I can see what's x cubed over x. What's 4x squared over x? What's 5x over x? So probably, if you are presented with a polynomial divided by a monomial, you probably want to do it this way. But you can do it this way. Same thing. We're really doing it this way now to practice our long division because sometimes this thing is not a monomial, it's a polynomial. We want to talk about that. Yeah. 4x squared divided by x. 4x squared divided by x. All right, think of that as a 1x. What's 4 divided by 1? And what's x squared divided by x? Okay, think of what the exponents are. 2 divided by 2 minus 1. Or you can expand it out. 4 times x over an x. Right? Oh, well, we like to utilize this subtraction. Right? Same thing. Subtract exponents. Quick question, yes?
So all of that equals 4x.
This divided by that is this polynomial. Well, x cubed plus 4x squared plus 5x divided by x is x squared plus 4x plus 5. Division. Oh, yeah. This divided by that is that. Just like when we went over here, this divided by that is that. It's division. Right? And you could write this or like this as well and do that same division. It does work. This is recorded. If you don't get everything, you can go back and see it. I just don't want to make sure we get it in before that bell's way early. We're going to kind of skip a little bit now to dividing by a binomial. There's a whole bunch of words here. Let's just do one. So now I've got x minus 1 into x squared plus 2x minus 3. Divided. Here's how it works. Everybody listen now. Can we find this little example on there? Yeah. Okay. What you do is, at the beginning, forget about the minus 1. Just look at the x. X times 1 is x squared. And you can do this. X. our next step? Multiply, right? But remember what we're multiplying, both these things. So what's x times x? And what's x times negative 1? Right? What's our next step? Subtraction, right? Well, what are we subtracting? This whole thing. So you got to be really careful. That's an x squared minus an x squared. If you did this right, that will always be 0. Well, what happens now? 2x minus negative x. Well, that's like a plus x, isn't it? What's a minus minus plus? 2x plus x? 3x. Bring down. Just watch, right? 2x minus negative x is the same as 2x plus an x. 2x plus an x is 3x. Bring down. Try again. X times what is 3x? X times, well, let's do this. Right? Good. Be careful you're not subtracting or dividing. So let's see. 3 times x, 3x. 3 times negative 1. And now I'm subtracting. 3x minus 3x is 0. Negative 3 minus negative 3. That's a plus 3. Also 0. So think of it. 3x minus 3 minus the same thing as 0. That's my remainder, no remainder. So if you divide x squared plus 2x minus 3 by that, you get this. If you multiply these back, guess what you get? That. And that's your check. You can do a FOIL on those. You should get that here. It's really complicated the first time you see it. I think I have time to do another example before we are interrupted again. I'm going to do this one right here, which if you're looking on your paper, it's on the back there. It's B under the examples on the bottom. Because sometimes we have remainders. So 2x times what is 2x squared? Well, let's see. I'm just dividing the 2x squared by the 2x. There's my 1. X squared over x. X. Multiply. 2x times x. Again, these should always be the same if you're doing this right. And then x times a minus 3. Minus 3x. Subtracting carefully. Because what happens to this minus if I'm subtracting? It becomes a plus. 11x plus 3x, 14x. Bring down. 2x times what is 14x? 7. 7 times 2x. And again, if you're doing this right, this will always match. 7 times negative 3. Next step is a subtraction. A minus minus, gotta make that plus. Minus 9 plus 21, what's that? 12? That's my remainder. How do remainders work? You take the 12 and you put it over the divisor. But you have to put a plus. We didn't have to do this with numbers, it was kind of understood. With these we did. And there it is. There it is.